All right, 3.7 is graphing absolute value functions. So what does an absolute value graph look like? It's always going to be V-shaped. Sometimes it's going to be a right side up V, and sometimes it's going to be upside down. Sometimes the V is going to be really wide, sometimes it's going to be really skinny, but all absolute value functions are going to be V-shaped. And an absolute value function is going to be when your x, your variable, is inside of your absolute value. So the vertex is going to be the point where the graph changes directions. So if I have my V-shaped graph, the vertex is going to be right here. It's where it changes from decreasing to an increasing graph. To find the vertex, you're going to set what's inside the absolute value symbols equal to 0 and solve. Okay, that's going to be the x-coordinate of your vertex. To find the y-coordinate of your vertex, you're always going to look at what's being added or subtracted at the end of your equation, which we learned in our 3.6 notes is your vertical translation number. Okay, so if I'm given my absolute value equation, in this form, I'm going to set what's inside the absolute value equal to 0 and solve it. That'll give me the x-coordinate of my vertex. So I would add an h over, which means that x is h. And then k, my vertical translation number, is always going to be my y-coordinate. So I end up with going to be the vertex h comma k. Now right here I have it as the opposite of h comma k. The reason is if all I have is x minus some number, it's always just the opposite of what that number is. So if this had been x minus 3, I know that my x-coordinate of my vertex is going to be a positive 3 because it's the opposite of what was originally here. So we've got 3 steps. Step 1 is to find the vertex to help us graph it. Step 2, you're going to make a table of values with the vertex as your middle value. So if my vertex is at 0, 0, for example, then I'm going to make an XY table where 0, 0 are my middle points. I'm going to pick 2 values bigger than my x-coordinate vertex and then 2 values that are smaller. Then all I have to do is plug each of these numbers in to my equation for x and then solve it for y. That will give you the numbers that go in those spots there. And that's 5 coordinate points. Those 5 coordinate points will make a V. Now, it is important that your middle number in your table has to be your vertex. If it's not, then you're not going to get the whole shape. It's possible for you to graph the points and only get 5 points on this side of the line. And if that's the case, it looks linear, and it's absolutely not linear. So you have to make sure your vertex is your middle number so that you have points on either side of it, so you get the entire V, not just one side of the V. Okay? So this part here, we've already written down in our vocab, so you don't necessarily need to write that down again, just going back over and summarizing that vertex. The same thing here, vertex form, we've already talked about it. So the one thing we didn't talk about was the line of symmetry. It's always symmetrical about the line x equals h. In other words, when you solve for this value right here, that value, x equals your number, is always going to be your line of symmetry. It's where you could draw a line through the graph and it would be symmetrical on either side. So if I've got my V, if I were to draw a line right here, it'd be symmetrical on either side of that line. So one thing to keep in mind, as I told you, it's going to be the opposite of this number here, comma this number. That's true unless you have a number in front of your x inside the absolute value. So that's your horizontal stretch or shrink. Then that's going to be a little bit different of a vertex, which is why if you make sure that you always are just setting it equal to 0, like we talked about right here, you'll be able to find that vertex okay. All right, so let's start by taking a look at these problems. So I want to know what the vertex is of this one. So the vertex of this one, if I set x minus 2 equal to 0 and solve it by adding a 2 to both sides, I'd get the x value is 2. So that means my vertex is 2, 7, because it's always this answer, comma, this number here. So try those next ones and see if you can come up with it. Okay, so I have x plus 1 equal to 0, which means that x is going to be a negative 1. So my vertex would be at negative 1, negative 2. Negative 1, positive 2, because this is a positive 2. We keep that number how it is exactly. The next one, this 3 out in front, does not change the vertex at all. It's going to make it a skinnier graph. It's going to make it go up faster, but it's not going to change the vertex. So I still set x plus 1 equal to 0. What's inside my absolute value equal to 0. Subtract the 1 on both sides, and that gives me the x-coordinate. So this is going to be -1, -3. My y value is always just that number. On the next one, if I set 3x minus 4 equal to 0, notice this time the 3 out in front does affect it because it's in the parentheses. So I would add a 4 to both sides first, and then I divide by 3 on both sides. So I would get x is 4/3, which is the same thing as 1/3 or 1.3 repeating. And there's nothing being added or subtracted at the end. So that means my vertex would be at 1.3, 0, because technically I do have a plus 0 here. And the last one, again, set 5x plus 10 equal to 0. What's inside the absolute value? Set it equal to 0. If I subtract a 10 on both sides and then divide by my 5, I get x as a -2. So that's a -2. My y coordinate is also a -2. So once you have your vertex identified, then it's just a matter of picking two numbers bigger and smaller than it to be able to graph it. So where would my vertex be on this one? Well, if I set x equal to 0, what's inside the absolute value, I can see my x-coordinate is 0. There's nothing being added or subtracted here, which means my y-coordinate is also 0. So then I pick two numbers bigger and two numbers smaller, and then I'm going to plug those numbers in. So when I plug in a 1 for my x, the absolute value of 1 is 1, and then I do 1 times a half, which is a half. When I plug in a 2, the absolute value of 2 is 2. 2 times a half is 1. When I plug in a -1, the absolute value of -1 is a positive 1, and a positive 1 times a 1/2 is 1/2. When I plug in a -2, the absolute value of -2 is 2, and 2 times a half is 1. And then I graph those points. So I have the point -2, 1, -1, 1/2, 0, 0, 1, 1/2, and 2, 1. And connect them, and I have my first absolute value graph. Notice it is a V-shape. We can talk about the transformations. So when it says compare the graph to the original graph to your parent function, this 1/2 is out in front. Out in front means it is going to be vertical. So this is a vertical shrink because it's a number smaller than 1. Vertical shrink by a factor of 1/2. In other words, it's going up half as fast as the original parent function would be going up. Domain and range then. So domain is what values can x be? So how far left and right does the graph go? So technically I could have picked more numbers. I could have picked a 3, I could have picked 100, I could have picked as many numbers as I want. I could have picked a -3, a -1,000, it doesn't matter. I could extend this table as much as I needed to, which is why I drew arrows on it. It shows that it's going to continue in that same pattern forever and ever and ever. So because as my arrows are going left and right forever, they're going to continue going up, That means that my domain is actually going to be, domain is all real numbers. In other words, it's going to go left and right forever. So that's my domain. My range, again, is what can y be. In other words, how far up and down does it go? So again, if I take a look at my graph, it's going up forever. So as it's going left and right, it's going up forever. But it stops here. It doesn't go any lower than that point there. So that means that y has to be greater than or equal to 0. The lowest point it goes to is 0, and then it can go up forever from there. So everybody try number 2, see if you can make your table of values and then graph it and describe the transformations, domain, and range, and then check back in. Okay, so I set what's inside my absolute value equal to 0, which just means my vertex is at 0, 0, because nothing is being added or subtracted after there. So then I will pick my numbers bigger and smaller, and then I will plug those numbers in. So we'll start with -2. When I plug in a -2, the absolute value of -2 is 2, but then this says take the opposite of that, so it's actually going to be -2. When I plug in a -1, the absolute value of -1 is 1, and then the opposite of that would be a -1. When I plug in a 1, the absolute value of 1 is 1, and then I take the opposite of it would be -1. When I plug in a 2, the absolute value of 2 is 2. The opposite of 2 is -2. So then I can graph these points. What do you notice about this graph? The whole thing is upside down. That's because this negative out in front makes it a reflection over the x-axis, which is the exact same thing we learned about in 3.6. For linear equations, the transformations are the same for absolute values. So if you've memorized it once, it's good to go. You will continue to use it for these problems as well. And then what's the domain and range? Well, the domain is still going to be all real numbers because it's going left and right forever. And the range on this one, well, this time it goes down forever, but it has a highest point. The highest point it goes to is at 0. So this time y has to be less than or equal to 0 because it's going down from there. Remember, any of these you have questions on, mark them, star them, so that tomorrow in class you can have me go over these with you individually so that you can understand them a little bit better. All right, let's try 2 more and make sure that we've got it. So start by finding your vertex. So I set what's inside the absolute value equal to 0, which would be 0. And then it's -3 would be my y coordinate. I'll still pick 2 numbers bigger and 2 numbers smaller. And then I'm going to plug each of those numbers in. So if I plug in a -2, the absolute value of -2 is 2. And 2 minus 3 is -1. When I plug in a -1, the absolute value of -1 is 1. 1 minus 3 is -2. When I plug in a 1, the absolute value of 1 is 1. 1 minus 3 is -2. And when I plug in a 2, the absolute value of 2 is 2. 2 minus 3 is -1. So let's take a look at this graph. And I've got it. Okay, notice that it's symmetrical. If this is my vertex, notice that my y coordinates on either side of it are symmetrical. It goes -3, -2, -1, -3, -2, -1. That's what it's always going to be. If not, you've either done your math wrong or you've incorrectly found where the vertex is. Maybe you found a point farther away than from where the vertex actually is. So what's my transformations? Well, subtracting a number outside means that it is a vertical translation down 3. And you can see it does in fact show that my vertex was shifted down 3 from where it originally is at 0, 0. What's my domain going to be? Well, domain is still going to be all real numbers. It's still going left and right forever, and that's the case for all of our absolute value graphs. And what's my range? My range is this time is going to be y is greater than or equal to -3. The lowest point it goes to is -3, and it opens up from there. Try this last one and then check in and see how you did. All right, so x minus 2, I set that equal to 0. When I add a 2 to both sides, I can see my vertex is going to be at 2, 0 because nothing is being added there. So then when I pick 2 numbers bigger and 2 numbers smaller, I can plug those numbers in. So this time I plug the number in, add 2, and then take the absolute value at the end. So 0 plus 2 is 2, the absolute value of 2 is 2. When I plug in a 1, 1 plus 2 is 3, the absolute value of 3 is 3. When I plug in a 3, 3 plus 2 is 5. Oh, wait. See? I'm seeing that I made a mistake. Do you guys see that? I was able to catch my mistake because I noticed it wasn't symmetrical. And what was my mistake? This should have been x plus 2, which means I was actually subtracting a 2 from both sides. So let me fix this and we'll try that again. Okay, so it's at -2, 0. It's so nice to catch your mistakes. Noticing those trends, noticing those patterns helps you catch your mistakes. We all make mistakes. It's totally okay. But that means that I needed to pick different numbers for my table. Okay, you guys see that? It wasn't symmetrical around my vertex, so I knew I'd made a mistake. All right, so let's try this again. Plug in a -4. -4 plus 2 is -2. The absolute value of -2 is 2. Plug in a -3. -3 plus 2 is -1. The absolute value of -1 is 1. Plug in a -1. -1 plus 2 is 1. The absolute value of 1 is 1. And I plug in a 0. 0 plus 2 is 2. The absolute value of 2 is 2. Now it's symmetrical. That looks much better. And I know that now I can graph my points. All right, I connect them, add my arrows to show it continues. The domain is still going to be all real numbers because it's going left and right forever. The range on this one, it doesn't matter that it was shifted to the left at all. The range is still y is greater than or equal to 0 because the lowest point my y value goes is 0. It wasn't affected by it being shifted to the left 2. So this would be a horizontal translation left 2 because it was inside and it's the opposite of the direction you think it would be. You can also see the vertex is shifted left 2 from the original. All right, take a second, write your